static forces we had done, force of gravity. Okay, so here was the starting of pressure, and in the pressure we had defined pressure to be force per unit area. So here we observed the word pressure, it's given as force per unit area. So whatever is the amount of force that acts per unit area, it is called as pressure. Now we had observed if area is less, so there will be more pressure exerted by it. If area is more, so pressure exerted will be less. And we had seen certain examples. Somewhere we try to decrease pressure, somewhere we try to increase pressure, and it's very easy if you increase or decrease the area. So like we had seen a bed of nails, we had seen the strips of bag. So all of them, they are designed in such a way to have an effect on pressure. In the last class, we had also discussed about pressure exerted by liquids. So how do the different liquids exert pressure? So here, we had done this activity. Okay, so in the similar way, we had not done this activity. In the similar way, we had done an activity like this. Pressure exerted by water at the bottom of a container. So see,
Sir,
yes,
sir, can you explain the first question in the test that was conducted last Sunday?
uh, do you remember the test?
Uh, no. It was about some experiment
Oh,
about with a
just one
straw.
1 minute.
So yesterday, the last of the test papers could you show, sir?
Yeah, this is the paper. Give a reason why a straw is rubbed with woolen
No, sir. Like
cloth.
our answer sheets.
Yeah,
Answer. Okay.
that too.
So this is the question. I have already sent answer sheets to ma'am. Okay. You can ask from her. She will be providing you. I have already provided answer sheets. Okay. So see which question you had doubt in.
So the first one itself.
Okay. Give reason why a straw is rubbed with woolen cloth attracts another straw. So see when
Yeah.
a straw is rubbed with woolen cloth, some charges are transferred from the woolen cloth to the straw, and hence the straw becomes positively charged. So when the straw is brought near another straw, so it attracts another straw because of the electrostatic forces of attraction. So
So
this
can you
was the
explain one more time? Your voice is breaking.
okay. You need to explain here 2 points. In the first point, you need to explain that there has been transfer of charges from the woolen cloth to the straw. Okay. So due to the transfer of charges from the woolen cloth to the straw becomes charged. And when you bring the straw near another straw, so because of the electrostatic forces of attraction, this straw attracts another straw. So the 2 points that you had to mention was first was that transfer of charges. First, you had to mention about the transfer of the charges, and second, you had to mention about okay. Second, you had to mention about uh, electrostatic forces of attraction which are there between the straw. Got it? Any other question you had doubt with?
No, sir.
Okay.
So the
So can
second
you,
question was gravity, right?
yeah, give a reason why a coin released from hand it begins to move downward. That is gravity.
Okay, sir.
So any other question? Anyone has any doubt? You can see you have all the questions here. Yes, yes, Lasa.
Uh, Sir, like the question papers are with, like our answer sheets are with whom, sir?
Your answer sheets are with Manisha ma'am. You can
Okay.
message her or I will tell her to send your answer sheets somehow.
Sir, like I want to know like where I lost my marks.
Okay, okay. So answer sheets are even with me, but I can't show you right now. If you ask mom, she will be sending it to you.
Okay, sir.
Sir,
Okay. Yes.
what is the end time of this assignment, sir?
Yeah, the end time was 5 p.m. All the test, it starts at 5 p.m. Saturday and it ends 5 p.m. Sunday. So you have 24 hours time. Within that 24 hours time, you can attempt any time your test.
Okay, sir.
Okay, so this week you will be having an objective test which will be for 20 minutes.
Okay, sir.
Objective, okay, and it will start from 5 p.m. Saturday to 5 p.m. Sunday.
Okay, sir.
Okay, so can we continue now about the atmospheric pressure?
Yes, sir.
So here you see we have taken two containers. You can see you have a container 1 and a container 2. Two containers are taken, and in the first container you have filled a lesser amount of water, and in the second container we have filled a larger amount of water. Okay. So what do we observe here? Okay. So what happened here? Here the water is filled half in this, and here you have almost fully filled. At the bottom of it, we have applied balloons. We have put two balloons here at the bottom of them. Now, the first balloon, you can see it has not swollen up much. It has swollen up less. And the expansion of the second balloon is more. It has expanded a lot. So the reason being, the pressure exerted by the second column, second liquid, is greater, and pressure exerted by the first one is lesser. Okay. Why the pressure on the second one is greater and on the first one is less? It is because of the height of the water. The height of the water on the first one is less, and height of water on the second one is more. So that is why the pressure exerted by the liquid is more on the second and less on the first. So we had seen this in the last class, that pressure exerted by the fluids is directly proportional to the height of the fluid. And I had told you the same thing with some other activity, like you take a water bottle, you create certain holes on it. You create holes one above the other. So the water from the bottommost part of the bottle, it comes faster. The water from the bottommost part comes faster, and the water from the top part, it comes slower. So which presents that the pressure at the bottom is more and pressure at the top is less. Okay. Now here you have the second experiment. We had also seen about the second experiment. So in the second experiment we are seeing, okay, take a plastic bottle. You can take a discarded bottle or a soft drink bottle, and for a cylindrical glass tube, so you have to make an arrangement something like this. Okay. So what happened here? When water is filled in this, so some of the water, due to the pressure of the water, this balloon expands. So in whatever side you put this straw, the balloon will expand, showing that pressure is exerted. Pressure is exerted due to the potential head of the water. Okay. Due to the height of water, some expansion of balloon takes place. So that means due to the height it water creates a pressure, and hence the balloon expands. Got it? Okay. Just one. Just one. I'm not able to get the board here. Okay, I'm not able to turn on the board right now. Let's continue with some other way. Just one minute. Let's continue here. Okay, so I think now everyone can see the screen here also. So we had seen the pressure exerted by water due to height. So pressure is, we had seen that the pressure is directly proportional to height. So we can write here pressure is directly proportional to height. If you have a greater height, so you will have a greater pressure. Pressure will be directly proportional to height. Now today we'll be mainly discussing about the atmospheric pressure. Let us discuss how the atmospheric pressure is. So we have a column of water here. Suppose, okay, everywhere around the surface of Earth, we have air. Air is present everywhere. Is air present everywhere around us?
Yes, sir.
Yes. Okay.
Excuse me, sir.
Yes.
Sir, this is pressure. The first slide, sir. Pressure is equal to height.
Hmm.
That what you wrote. It's weight or height, sir.
Pressure is not equal. It is proportional to height. Pressure is not equal to height. Okay. It is
It's
proportional to height.
Okay, sir.
Yeah. Proportion.
It's
Proportional
proportional
means,
to height.
yeah.
Okay, sir. Thank you.
Okay. So if we observe our surface of Earth, so everywhere around the surface of Earth, we have the atmosphere, right? So if you have this, our Earth, and around the Earth, we can consider our atmosphere. So let's say currently I'm not able to use my board, so maybe I'm having some problem here. Okay, so let's see. I think now I can use somewhere for writing, and we can continue. Okay. So now the atmospheric pressure. See, atmospheric pressure is the pressure exerted by the atmosphere above the surface of Earth. We know that our Earth is covered with air. So here you see the diagram that our Earth is covered with air everywhere around us. We can observe our Earth to be covered with air. Let's say this is our Earth. And around the Earth, you have the atmosphere. And as we know, the atmosphere has air molecules. There are air molecules. And tell me, is air a matter or not? Is air a matter?
Yes, sir.
Yes, sir.
Yes. So air is a matter here. That means air will have some mass, and all the particles or all the molecules of air, they are pushed downward due to the gravity. Gravity pulls all the air molecules towards it. Therefore, all the air molecules, they exert a pressure on the surface. All the air molecules, they exert a pressure on the surface of the Earth. And this pressure exerted by the air molecules on the surface of the earth is called atmospheric pressure. So here, if we take any portion of the earth, it's just like this. How do I tell you then? Okay, again see. So this,
Sir,
yes.
I didn't understand the bottle and the balloon example you said. No, sir, I didn't understand.
Okay, water and balloon example. Just 1 minute. This one, just let me show you again. So this example,
Yes, sir. Yes, sir.
the second one,
Yes, sir.
okay, this one. See, in this activity, we want to show that water or any liquid, it exerts pressure on the walls of the container. Okay, so if you have water or anything, it exerts pressure on the walls of the container. That means water which is filled inside this, it is trying to push the walls of the container. It is trying to push the bottle in every direction. It is trying to push the walls of the container.
Yes, sir. Yes, sir.
Okay, and to prove that, we have put a straw into the water bottle, and on that straw we have mounted a balloon. Okay, so we observe here that the balloon expands. The expansion of the balloon shows that the water is exerting a pressure on the walls of the balloon. That is why the balloon expands.
Yes, sir.
Okay, so in
Sir,
this
but what
activity,
does anything have, what does the height of the water do with the expansion of the balloon?
yeah. So as we have just seen here, that the height of the water is directly proportional to the pressure. Okay, so if you fill water to a greater height, it will create a greater pressure, and hence the expansion of the balloon will be greater. Got it? Yes. So any other doubts? Shall we move to the atmospheric pressure again?
Sir.
Okay. Okay. Okay, so this activity I already told you here that if you put holes at same height, you will get water coming out with the same speed, and the water will fall to the same distance. Okay. So this proves that what pressure is exerted in all directions, which is equal. Pressure exerted in all directions by the water molecules is equal. Okay. Okay, see.
Sir, excuse me, sir.
Yes.
Sir,
Yes.
this spot example could you explain again, sir? I got to request issue and I rejoined again.
Which one?
This 11.16, sir.
Okay, this one. So this
Yes, sir.
activity we had done in previous class also, that you take a water bottle and you create some holes. You create some holes at different places, but at the same height. So all the holes, they are created at different places but at same height. So see,
Yes,
all these holes, they are at the same height but at different sides. So on all the sides we get the same pressure. The
yes,
water is so the water from all the sides, it travels the same distance and it comes with the same height. So it shows that the pressure at all the points is same. Okay. So from this we consider that pressure due to a liquid, that is water, is directly proportional to the height, and it is on all the sides it's the same. The pressure exerted on, yes, the pressure exerted on all the sides of the bottle or the container is same. Now let us move towards the atmospheric pressure. The atmospheric pressure is the pressure created by the air around the earth. So the air around the earth, it exerts a pressure. See this example. This is a portion that has been shown. If you see here, this column has been shown. So this is the column of air, the column of air which is above us. So this column of air, it must have some weight and it must exert some force in the downward direction. It must exert some force here in the downward direction. Okay. So therefore, if we have a force that is being experienced by the earth due to air, so the earth must also experience a pressure where the pressure will be given by force per unit area. Got it?
Sir, can you explain again?
Which part? Atmospheric pressure?
Yes, ma'am. Yes, sir.
Sir, this example, sir. Could you explain again?
Okay, this example. Just one minute. Okay, let's try to do it like this. Suppose you have this earth, and around the earth you have, we know that around the earth we have air molecule. Okay, gas or air is present around the earth in the form of
Yes.
earth atmosphere. We know, we call it to be the earth atmosphere, right? So suppose this is the thickness of the air that is present. We have everywhere around us. This is the air that is present around us. So as we know that air will exert, this air exerts a force on the wall of the, this air exerts a force
On the surface of the earth.
on the surface of the, so from all the directions, it is exerting a force on the surface of the earth, right? So as you can see, all the force is normal to the surface. So hence we can find out the pressure. There will be some pressure exerted by the, there will be some pressure exerted by the molecules. Okay, and this pressure can be calculated as force per unit area. We can find out the pressure by force per unit area. So this pressure will be given as force per unit area, and this, in this example, we have here, if you see this column, so we are just taking a portion of this. We are just taking a portion of the atmosphere. So this portion of the atmosphere, it exerts a force on the surface, and the area which is in consideration is this much. Okay. So pressure exerted will be force per unit area. So here we have taken a unit area. Here we have taken a unit area, and the force experienced by the earth per unit area will be called as pressure. So we call it as the pressure. Okay. So has everyone understood about the atmospheric pressure?
Yes, sir.
Okay. Anyone having any doubt about the atmospheric pressure?
Sir, regarding the Sunday this test, sir, we would have this also, sir, like atmospheric pressure.
In Sunday's test, yes. You have everything from this chapter.
Like till what we have completed. Like
Complete.
till this topic.
This chapter will be completed.
Okay,
It
sir.
is,
Sir,
yes.
why the water will always try to go out of the bottle, like you have said, no, sir.
Okay.
It exerts its pressure on the walls of the bottle, you said, no, sir.
Yes.
Why it does like that?
Sir, can you just give a brief summary of the atmospheric pressure? Because I'm not so sure.
Okay, just 1 minute. Just 1 minute. ठीक है, चलता है. Okay. So you wanted a summary about the pressure, atmospheric pressure. Who was that?
Sir, Shrestha.
Okay, sister.
Sir, even I, sir. Sir, even I, last, sir.
Okay. So let's see again. As we can see, pressure will be exerted. You will experience a pressure whenever you will have a force. So if you have a force experienced per unit area, force experienced per unit area, that we call as the atmosphere, that we call as the pressure. Okay. So whenever you will have any object, suppose if you are pressing any object, if you are applying a force on any object, so that object will experience a pressure, right? So here, consider here we have our earth. So this is our earth, right? And suppose this is your atmosphere. Now can you visualize how I have drawn? This is our earth, and above this you have the atmosphere, right? And the atmosphere is filled with air. So the air is attracted to due to gravity. All the air is attracted due to gravity, and hence we can assume that the air is pushing the earth. Can we assume like this? That air is pushing the earth? Yes?
Yes, sir.
Yes. So if we see that air is exerting a force on the earth, that means air is pushing the earth. Therefore, air must exert a pressure on it. Since earth has a certain area, right? Earth has a certain area, and all the gas molecules or air molecules, they exert a force on it. Okay. So you get the pressure as force per unit area. Got it? Got it? So it is atmospheric pressure is only the pressure exerted by the air molecules or pressure exerted by the atmosphere, pressure exerted by atmosphere on the earth. Got it?
Yes, sir.
Okay. So now you have understood that it is the air which is pushing the earth, and since it is applying a force, it is pushing the earth. So there is a force that is being exerted by the air on the surface of the earth. So this force per unit area will be called as pressure. So this pressure we call as the atmospheric pressure, since it is the pressure exerted due to the atmosphere. So hence the name is given as atmospheric pressure, right? Our atmosphere is exerting a force, a pressure on the earth. So that is why our earth is experiencing a pressure. So we have this atmospheric pressure. Now, can you say that the atmospheric pressure is present everywhere on the earth?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Okay, so the atmospheric pressure is present everywhere on the surface of the earth. And as we move up, it's just like you have a water bottle filled with water. You can see we have taken here a column filled with air. We have assumed air to be filled in a column, right? So this air is filled in a column, and hence we can assume it to be similar to that water bottle in which water was filled, which exerts a pressure on the bottom. So here, this is the atmospheric pressure, and this atmospheric pressure when exerted on at the sea level. So at the sea level, this atmospheric pressure is equal to 76 centimeter of mercury. 76 centimeter of mercury, and Hg is the symbol of mercury. So at that sea level, the atmospheric pressure is about 76 centimeter, and it keeps on varying at different places. Got it?
So 76 centimeters of mercury?
Yeah, 76 centimeter of mercury. Or we call this pressure to be equal to 1 atmosphere. Okay. So there, just look for a few seconds here. At the bottom, we have a diagram which explains that how much of the pressure is exerted by the air. So a diagram below will explain the amount of pressure exerted by air. So just explain. After that, we will move on to the next one. See here at the bottom, you have this example of two metal ball. Okay. So here is a metal ball. This metal ball was cut into two halves. Okay. The metal ball was cut into two halves, and all the air which was present inside it, it was removed. A vacuum was created inside it by pulling out all the air. So all the air was pulled out of it. It was not made to stick by any glue, or it was not welded together. The only thing that was done is that all the air was pulled out of it. Okay. So it was only the atmospheric pressure. Here it was only the atmospheric pressure or air that was pushing this. So it was air only from the atmosphere that was pushing these two spheres together, and
Sir,
hence holding.
the middle ball
Yes.
is metal ball, right, sir?
Yeah, it was a metal ball. It was first cut into two halves. It was a hollow. It was a hollow metal ball which was cut into two halves and then rejoined. It was just joined together, not welded together, just kept together, and all the air from it was removed. Okay. So when all the air from it was removed, then it was only the atmospheric pressure which was keeping it intact. Okay. So here, now he tried to pull the two metal balls apart again, but he was not successful in pulling these two apart even after using 8 horses on both the sides. So we have such a strong atmospheric pressure. Our atmospheric pressure is very strong. There are, we'll try to understand different phenomena which occur because of the atmospheric pressure. It is because of the atmospheric pressure that we are able to suck juices through the straw. Got it? Okay. Okay, so bye all of you. See you again in next class.
Bye, sir.
Okay, bye.
Thank you, sir.
Okay.